Jai Hind to all. My name is Divya Sharma. Now, today's video lecture is on short electric dipole. So, before we'll start with the short electric dipole, you should know what do you mean by retarded potential or time varying potential, right? No, now consider an antenna. First, you should know, let it be as you have studied in the signal, that let it be this is a signal, this is 2, this is a signal, right? How you can find out u? So here u t minus 2, right? This is the signal of you have studied in signals. So here what you have to do, this is your short dipole, this is your uniform state conductor. Here is a point P, and distance between this short dipole and P is a point. So there is a distance in between this short dipole and P is r. Now angle, when you are drawing a line, means when you are connecting this short dipole to this point P, here are some points are also there. This you can consider as P, right? Now here you are considering this is a point P, and this is a distance in between this short dipole and P, that is r. Now angle between this line and to this uniform straight conductor, that is equal to theta, and this is short dipole, that is represented as dl. Now current is flowing in this straight conductor, short electric dipole, that is represented by I. So instantaneous current, this is, or you can say, let us consider this is an antenna. This is an antenna. Here this some current is flowing in this antenna, and this, let us consider this is a point P. So you have to find out power, right? So power at this point you have to find out. Let us consider this is a point and it is represented as P. So you have to find out power at this point. So there are so many points. You can consider any point nearby this antenna that is represented as P, and you have to find out power. And power is what? Power is equal to E cross H. It means what? Electric field into magnetic field. Now here electric field, it means you have to measure electric field. E is equal to what? E is equal to minus j omega A vector minus del V, right? Now H is equal to what? Magnetic field is equal to del cross A vector. So if you are finding power at this point, you should know electric field and magnetic field. So when you are finding power at this point, so there is some electric and magnetic field, right? So you have to find out here electric field. Electric field means E is equal to minus j omega A vector minus del V. H is equal to what? Del cross A vector. So you should know A, you should know V, you should know A here, then only you can find out E and H, right? So electric field and magnetic field. Now when you will know electric and magnetic field, then you should know this E R, E theta, E phi, and here for H, R, H R, H E theta, H theta, H phi. So these are the parameters you should know when you are finding E and H, and when you will get the information about E and H, then you can find out the power. And if you want to find out average power, because there are so many points and you have to find out power nearby this antenna. So nearby this antenna you have to find out P average. So P average is equal to what? Half real E cross H. So this is the concept regarding this short electric dipole, means you have to find out average power at this point P. Now when here is current is flowing in this conductor, so I is equal to what? Instantaneous current. It means I is equal to Im sin omega t. Im is what? Im is maximum value of current. Omega is angular frequency, t is time. So this is instantaneous current. If you want to find out retarded time means there is a distance r, and you all know the velocity of light, so that is represented by c. So if you want to find out retarded time, it means what? I is equal to Im sin omega t minus r by c. means distance upon speed, that is also time. So this is your retarded time. If you want to find out retarded time from this point to this point, then you have to find out retarded time, that is represented as I is equal to Im sine omega in bracket t minus r upon c. So this is retarded time. Now here first you can write down this, if it is retarded time, it means t minus r upon c retarded time. So you will get this equation I is equal to Im sine omega t minus r upon c. Now let us, you all know a uniform wave traveling in positive z direction. Let us consider, you are considering here for short electric dipole, you are considering this is your z axis. If it is z axis, or you can say if it is a positive z direction, so Ey is equal to sine omega t minus beta z, or at a distance r, or at a distance means you are considering here distance r in the figure, so z is replaced by r. So Ey is equal to sine omega t minus beta r, and beta you all know, beta means what? Angular velocity omega upon velocity of light, omega c, and omega is what? Omega is 2 pi f, f represent frequency, or this is beta, beta is your phase shift, 2 pi f upon c. So put here the value of beta, beta is equal to 2 pi f upon c, this is your phase shift. Now put this equation, means put this beta value here, and you will get here Ey is equal to sine omega t minus omega r upon c. So here put the value of beta in form of omega and c. So omega upon c, here put the value beta, and you will get here sine, you can take omega as a common, sine omega t minus r upon c. So this is your Ey, Ey is equal to sine omega in bracket t minus r upon c. So this is your retarded Ey, right? E is electric field. Now here from equation 3rd and 4th, so this is equation 3rd, Ey is equal to sine in bracket omega t minus beta r, and this is 4th equation, Ey is equal to sine omega t minus r upon c. So equate this equation, means you can write down equation 3 is equal to equation 4. From equation 3 and 4, sine omega t minus r upon c is equal to sine in bracket omega t minus beta r. Okay. Now let us consider, this is your 5th equation. Now retarded time in exponential form. So here you are getting retarded time in form of sine omega t minus beta r. So you have to write down retarded current in exponential form. Retarded current is I is equal to Im sine omega t minus r upon c, right? So sine you can write down in form of e, exponential term. So I is equal to Im e ki power j omega t minus r upon c, and you all know you can put the value here. Beta you can beta can come inside, and you will get here omega t is equal to omega r upon c. So omega upon c is equal to what? Beta. So this is your current, retarded current. Now if you want to find out retarded current density is represented by J, and J is equal to what? Maximum current density or retarded time in form of here J is equal to Jm e ki power j omega t minus beta r. So this is your ampere per meter square. This is your current density. Now you have to find out magnetic vector potential is given by what? Magnetic vector potential is represented by A. So A is what? A is equal to mu upon 4 pi. So here you are taking integration in form of volume. So dV. So take here triple integration J upon J is what? Your current density upon distance into V, dV. So integrate it and you will get here magnetic vector potential. Mu is what? Mu is representing here permeability of free space. So here this is your vector potential, and you have a need when you are finding electric field, E is equal to minus j omega A vector minus del V. So there is a need of A vector, right? So first A vector, you should know A, R, A, theta, A, phi. You have to find out all these things. Now here A is what? A is equal to mu upon 4 pi integration V j upon R dV. Now here substituting the value of j from equation 7 to in 8, you will get here A is equal to mu upon 4 pi integration V. Here you are putting the value of j So Jm e की power j omega t minus omega r upon r dv. So this is the expression of retarded vector potential. Now here, short electric dipole. Any linear antenna consists of large number of short conductors connected in series, but here you are considering small part of the short electric dipole. So you are considering here are large number of short conductor, but here you are considering one short conductor. So a short linear conductor is known as short dipole or Hertzian dipole. So this is your short dipole antenna, where you can see this is your transmission line, these are your end points, and distance between these two end points, this is d. So sorry, this is the length, means this is the this is your d, and these are your end points of this antenna. Here you can see you are considering charge on these end plates. Charge are equal on these end plates, but in opposite sign. So you are considering here charge q. Here is also charge q, means equal charges you are considering at the end of these plates of the antenna, but charge is different. Here you are considering positive charge, here you are considering negative charge. So current is flowing in this straight conductor, or you can say short dipole, that is represented by R, and length of this dipole, short dipole, that is represented by L. So you can consider this is an equivalent circuit of this antenna. Now L is the length of the dipole, which is very short as compared to the wavelength, means L is less than lambda, and D is the diameter of the dipole, D is the diameter of the dipole, which is very small as compared to its length, and D is less than L. Now I is equal to what? As you all know, I is equal to dq upon dt. So there is a relation between current and charge, that is I is equal to dq upon dt. Now fields of short dipole. Here you have to do a derivation of field of short dipole. Consider here a dipole of length L is placed along z axis with its center at the origin. Let a current is flowing in the dipole, and P is a point at the distance r from the center of the dipole. Now here, this is your dipole, short dipole. Let us consider this is your point P. Your coordinate, P's coordinates are r, theta, phi. Now here, when you are considering short dipole, so its short dipole length is represented by L. Distance between this center of this short dipole and this P point is represented by R. Now here, find out the direction of E theta, E phi, E r, E theta, E phi. Now let us consider this is your radius, right? So here you are considering a sphere, and distance between this P point and center of this short dipole is represented by R. So this is the direction of ER, right? Here you have an angle of phi. So direction of phi is in this direction. This is your direction of phi. So your E phi is equal to what? This is your unit vector of E phi, and this is the unit vector of ER. Now third is E theta. E theta is, you are considering here, this is the theta angle between short dipole and this point P, line distance between this point P. So here the direction of theta is what? Theta's direction is this. So here you are considering E theta unit vector is this. Now here, the effect of current in dipole is not felt instantaneously at point P, but after some time this is known as retardation effect. Now let us consider an equivalent circuit from the previous figure. This is your short dipole, and length of this short dipole is represented by L. This is a point P. So distance between center of this short dipole to this point P, this is the distance R, which is from the center of this dipole and this point P. Now this is start point of this short dipole, this is end point of this short dipole. So start point of this dipole to P point is represented by S1, and this is the end point. So end point distance in between this point, end point, and this point P, that is distance is S2. Now let us consider DZ, small part of this dipole, that is represented by DZ, and center from center to this small short dipole is Z. So you are considering here differential Z. Now here distance between this short dipole to this point is represented by S. Now this is the geometry of short dipole. Now here write down a current, means you have to write down instantaneous propagation of current. I is equal to what? I is equal to I0 e की power j omega t. Now if you want to write down this current in form of retardation, means retarded current, so I is equal to what? I is equal to I0 e की power j omega t minus r upon c. So this is your retarded time, means if there is a retarded effect on this current, so your retarded current is equal to this. Now here you have to find out the retarded vector potential. Now retarded vector potential AZ is equal to what? Mu 0 upon 4 pi. Now you have to consider the limits of this integration. Now in this integration I upon s dz. So limits of this integration is, here this is the distance L, and if you are considering half of this dipole, then L by 2. So limits are from minus L by 2 to L. So now here I is the retarded current given by equation 2, previous equation. Now I0 is the peak value of the current, mu 0 is the permeability of free space. Now if R is greater than L and lambda is greater than L, so distance s of an element dz from point P may be taken equal to R. At a large distance, s is equal to R. So this equation will become this: Az is equal to mu 0 upon 4 pi I upon s. You can take outside this integration and you have to integrate this dz with limits minus L by 2 to L by 2. So you will get equation Az is equal to what? Mu 0 I upon 4 pi R into L. Now here this is your I, current. So substitute this value current in form of retarded current. So retarded current means I0 is equal to e की power j omega t minus R upon c. So this is your Az. Now retarded potential is represented by V of a charge distribution is equal to what? You should know V is equal to what? 1 upon 4 pi epsilon naught in integration rho upon s d tau. Now rho is what? Rho is retarded charge density. And if you want to find out retarded charge density, so retarded charge density is rho is equal to rho 0 e की power j omega t minus s upon c. Now here d tau is what? Infinitesimal volume element, and epsilon naught is permittivity, or you can say dielectric constant of free space, that is its value is 8.85 into 10 to the minus 12 farad per meter. Now if you have, this is your short dipole. Now you have to consider in the previous figure your P point is this, and you have to find out distance from start point to this P, end point to this P, center to P. And if you are considering short dipole, part of this short dipole, that is represented by dz, so you have to find out the distance from this short dipole to P, that is represented by s. So here you are taking an equivalent circuit for this, and this is the start point. Let us consider this is the end point of the dipole, this is the center. So here start point to this point, let us consider this is a point. So start point to this point, point of this dipole is to this point P, distance is S1. Now from center to this point P, distances R, and the third one is distance S2. Now you have to take a symmetry, you have to take an axis. So if you want to take an axis to this, let us consider this is Z axis. So you have an extra part, this is your L by 2 cos theta. So you can find out this is your theta. So you have to find out this distance, that is equal to L by 2 cos theta, and distance of this short dipole is represented by L. So you have to find out, to maintain this symmetry, you have to find out this distance and this distance. So this distance is L by 2 cos theta, this is also L by 2 cos theta. So you have to find out this whole distance, and you have to find out this whole distance. So S1 is equal to what? S1 is equal to L by 2. So you have to find out S1 is equal to what? L by 2 cos theta, and S2 is equal to what? S2 is equal to S2 minus L by 2 cos theta. Means you have to find out S1 and S2 in form of L by 2 cos theta. So here you have to write down the relation in between S and S1 and S2. So S1 is equal to R minus L by 2 cos theta, S2 is equal to R plus L by 2 cos theta. So you should know these two equations from the previous figure. Now you should know V is equal to what? V is equal to 1 upon 4 pi epsilon naught Q upon distance. So here distance means you are considering here S1 distance, S2 distance. So charge Q upon S1 minus Q upon S2. As you are considering these two charges are on the end point and start point of the dipole. So Q upon S1 minus Q upon S2. So put here the value of S1 and S2. And you have to put the value here Q also. So if you want to write down Q, so you should know this equation dq upon dt is equal to R. So find out this Q from this equation. Q is equal to what? Q is equal to integration I dt. And I, you all know, I is equal to I0 integration e की power j omega t minus s upon c. And now here Q is equal to what? Q is equal to, if you will integrate this exponential term, so you will get here finally Q is equal to I0 e की power j omega t minus s upon c upon j omega. Now here, so put here in this equation you have to put this value Q, S1 and S2. So when you will put this value Q, S1 and S2, you will get here V is equal to I0 upon 4 pi epsilon naught j omega, and write down here the term of Q. So here Q and S1 and S2. Here also when you will get this equation, so you have to put here the value of S. When you are considering this charge, so here put value S1, and if you are considering this charge, so here put the value of S2. So here you have S1, S2 and here you have S1. Now here, so you have to put here the value of S. When you will put this value, so you will get, finally you will get this equation V is equal to this equation. So here L square cos square theta by 4 is, you have to remove it from the denominator when you will get this value L square. So when you will put all these values, you will get, when you will multiply this, you have to take here, this is your equation. So put here the value of S1, put here the value of S2, here also put the value of S1, and here you have to put the value of S1. So you will, finally you will get this equation, right? Now when you will take LCM and you can multiply denominator and numerator, then you will get this value, and denominator to numerator, then you will get this value. So when you will get this equation, you have to remove the terms L. When you will multiply R into R, you will get here R square. When you will multiply this one to this one, you will get here L, R, L by 2 cos theta. When you will multiply this to this, R, L by 2 cos theta, and when you will multiply this to this, then you will get this term L square cos square theta by 4. So from this denominator, you have to ignore this term because R is greater than L. When you will ignore this, so you will get this equation. So here, when you will get this equation, this term is in exponential form. So you have to take this term in form of cos theta and sin theta. And you all know, if you have E theta, so you can write down it like this, cos theta plus j sin theta. So this is the previous term, and you will get here, so you have exponential term here. Now you have to put here exponential, you have to put here this exponential term in form of cos theta and sin theta. When you will put the value here, cos in form of cos theta and sin theta, and here also, so you will get here this equation. Now see this equation and see this equation. So here you have to consider cos theta is equal to 1, means theta is nearly equal to 0. Means cos theta is nearly equal to 1, cos theta nearly equal to 1, and in sin theta, theta is nearly equal to theta. So when you will consider these two terms, cos theta is nearly equal to 1, so here put here value 1, and sin theta is equal to theta. So sin theta is equal to what? Omega L cos theta upon 2c. When you will put these two values, you will get this equation. V is equal to I0 L cos theta e की power j omega t minus R upon c upon 4 pi epsilon naught c in bracket 1 upon R plus c upon j omega dot, means in multiplication 1 upon R square. So here you are getting V, and so after getting this V, you can find out electric field, because E is equal to what? E is equal to j omega Az minus delta V. So here this value is known to you now, and A already covered in the previous slide. So you have to find out Az. Sorry, Az is there. Now here you should know the Az value. So Az, so we can already we have done in the previous slide that Az is equal to what? So V is known to you, and you have to find out electric field intensity. Now electric field intensity, electric field of short dipole E is equal to what? E is equal to minus j omega A is equal to minus delta V, and H is equal to del cross A. And polar coordinates for vector potential A is equal to what? A is equal to R, AR plus theta, A theta plus phi, A phi. So here A phi is equal to what? A phi is equal to 0. So from this equation, AZ, AR and here theta. So you can find out AZ is equal to, sorry, AR is equal to what? AR is equal to AZ cos theta and A theta is equal to AZ sin theta from these two figures. So you now here you are aware about this AR, A theta and A phi is equal to 0. So you can put this value AZ, you can find out here AR is equal to AZ cos theta. So AZ is known to you from the previous slide. So you can put here the value of AZ. Here also you can put the value of AZ and you will get this AR and A theta. So del cross V is equal to AR means you should know here del V is equal to what? Del V is equal to AR, del V upon del R plus A theta 1 upon R del V upon del theta plus A phi 1 upon R sin theta del V upon del phi. So you know this equation, and E is equal to AR, ER, unit vector of R, electric field, unit vector of theta, electric field, unit vector of phi, electric field. So you know this equation in form of polar coordinates. So E phi is equal to what? That is A phi is equal to 0. So this is also 0. So E is equal to AR, ER plus A theta, E theta. So here you know ER is equal to what? Minus j omega AR minus del V upon del R. E theta is equal to minus j omega A theta minus 1 upon R del V upon del theta. So you can put here the value of AR, you can put here the value of A theta. So when you put in form of AZ, so you will get this equation. Now here you can put the value of AZ and here you can put the value of V in form of this polar coordinate. So this is here you are getting electric field. So E is equal to minus j omega E minus del V. So here V is known to you from this polar coordinate, E is known to you from these equations. So you can put these values in this equation and you will get here electric field intensity. So next electric, how to put all these values and you will get this equation. Try it, and in the next lecture we will cover this electric field and magnetic field. Okay, thank you.